Aloha! If we haven't met before, my name is Spaceman Steve, and today I'll be showing you how you can measure the speed of light with nothing but a microwave and some chocolate. So, if you want to play along at home, here's what you'll need. You'll need a microwavable plate, a ruler, a grater, some chocolate, and a microwave. And kids, if you're watching this, make sure you have an adult with you when you're doing this experiment. So before we actually run our experiment, we'll need to know a couple of things about light. Now I have a whole video on the nature of light if you're interested in all of the details, but here I'll just give you 3 of the basics. 1. Light is simply energy traveling in the form of a wave. And in a lot of ways, you can think of it just like waves on the ocean. Light waves have peaks and troughs, and the distance between 2 peaks or 2 troughs is called the wavelength. Unlike waves on the ocean though, if the wavelength is short, i.e. the peaks are close together, then the light gets bluer and has more energy. And if the wavelength is long, the peaks are further apart, then the light gets redder and has less energy. 2. No matter how big or small the wavelength, light always travels at the same speed, the speed of light, and this is what we'll be measuring today. It was Einstein who figured this one out. 3. Imagine that you were able to count the number of peaks that are going past you per second. This number is called the frequency of the light. You can think of it like how frequently waves go by. The frequency of light is measured in units of hertz, and that's named after the German physicist Heinrich Hertz. Hertz simply means the number of peaks that go by per second. So for instance, if 10 peaks were going by per second, then the frequency of the light would be 10 hertz. Since light always travels at the same speed, then the shorter the wavelength, the more peaks go past you per second, and the higher the frequency is. So the wavelength, the frequency, and the speed of light are all related to each other. And in fact, there's a simple little formula that tells us how. The speed of light is equal to the wavelength of light multiplied by the frequency of the light. So if we can find out the frequency of some light and then measure the wavelength of light, all we need to do is multiply those 2 numbers together and we can calculate the speed of light. Okay, here's where the microwave and the chocolate comes in. Microwaves cook food using light, so let's see if we can find the frequency and the wavelength of this light. Each microwave is designed to shoot light through this main chamber. The type of light is aptly called microwave light. And what it does is it vibrates the water molecules inside your food, rubbing them together. Now, just like if you take your hands and you rub them together really fast, you'll start to feel heat that's generated, and it's this heat that cooks your food. Now, through some very clever engineering in the electronics, and the actual size of the microwave chamber itself, the peaks and the troughs of the microwave light appear to stay in the same place when the microwave is turned on. This is called a standing wave. Food is only cooked where there are peaks and troughs. At these points, called nodes, there is not enough energy to vibrate the water molecules. This is why the food in the microwave spins, so it touches the parts of the light that are actually doing the cooking. If the food did not spin in the microwave, only certain parts of it would get hot, and you wouldn't get an evenly cooked meal. Okay, let's do this. Step 1. Take a look at your microwave. Somewhere on there will be a label, and if you read closely enough, you will find the operating frequency. If you have a standard microwave, this number will be 2.45 GHz. The HZ stands for Hertz, and the big G means giga, which is another way of saying billion. So what this is telling you is that the frequency of the light in your microwave is 2.45 billion hertz. Said in another way, that means that 2,450,000,000 peaks in the light wave are passing us by each second. Great! So now we have the frequency in our equation to calculate the speed of light. Step 2. Open the microwave and take out the spinning plate, and also the roller wheel that's underneath it. Step 3. Carefully grate some chocolate onto the back of a microwavable plate. We're using the back of the plate because when you took the spinning glass out of the microwave, there's a little bump that's left over, and the plate's going to be crooked if it was right side up. You need just a bit more than a light dusting of chocolate, so don't go too crazy. Step 4. Place the plate in the microwave and turn the power down low to about 10 or 20%. This is very important because if the microwave's power is still on high, the chocolate will burn and probably fill your microwave and then your house with smoke. Yeah, that happened. When you have the power down low, microwave the chocolate for about 20 seconds. Step 5. After it is finished, take it out of the microwave and tap it over the sink, brushing off all of the parts that did not melt. There should be a couple of spots, up to 4, that melted more than the other places on the plate. Remember, since the plate wasn't spinning, the only places that will cook is where there was a peak or a trough in the light. If none of your chocolate is melted, you need to redo the experiment and microwave for a little bit longer. And if all the chocolate is melted, it means that the power was too high or it was in the microwave for too long, and the heat from the melted chocolate was warming up its surroundings. So you might have to play around a little bit. Step 6. Once you see multiple places where the chocolate melted more than its surroundings, grab your ruler and measure the distance between them. This is the distance between a peak and a trough in the light, which is exactly half of the wavelength. I measure a distance of about 6.1 centimeters, so multiplying by 2, I find that the wavelength of this microwave light is 12.2 centimeters. If you have a ruler that only gives you inches, note that 1 inch is 2.54 centimeters. So, the frequency of our light is 2.45 billion hertz. Writing that out in a long form is 2,450,000,000 hertz. And the wavelength of the light is 12.2 centimeters, or 0.122 meters. But your number might be a little bit different than mine. Multiplying the frequency and the wavelength of the light together, our estimate of the speed of light is 298,900,000 meters per second. This is actually really close to the real value of 299,792,458 meters per second, or 11 million miles per minute. We're only 0.03% off. Wow, that's really fast. Step 7. Celebrate with your family and friends by eating all of the leftover chocolate. Success! How close can you get to the actual value? Give it a try. Well, mahalo nui, thank you so much for tuning in. Until next time, I'm Spaceman Steve.